Okay, you saw clearly where the points are, so I'm just kind of drawing them in here, and now I'm going to draw the curve. Now to get down here to 1/4, that curve has to be pretty flat down there near 0, and then I screwed it up on the right so it's not real symmetric. Actually, I screwed it up on the left. Okay?
All right.
But you probably do a better one than I did because you had a really nice graph there. Okay? So there we have it.
Okay.
There's our graph of y equals x squared. Well, we can do the same for x cubed, and we can do the same for 1 over x.
Mm-hmm.
Okay? These are all important functions, and there are more. Okay? And there is another one. Y equals 2 to the x. For this one, we don't use 1/2. Can you tell me what 2 raised to the 1/2 power is?
1?
No.
1/2?
No.
No.
No. You don't know. You can't tell me. Nobody can write it down exactly in decimal form. We're not going to use it. We're only going to do the numbers that you can do without resorting to a calculator, right?
Right.
So we're not using calculators for this.
Okay.
Okay? You don't need it, and you do need to be sure you understand the arithmetic. Okay? So, so we're not going to use 1/2.
Okay.
We exclude 1/2. We're not going to include that, okay? Because it can't be written exactly in decimal form, because you don't have a clue how anybody would evaluate that other than running to a calculator.
Right.
And neither does 99.99% of the rest of the population,
All right.
okay? And the 0.01% do know, which would include a lot of students sometime in their second semester of calculus,
Mm-hmm.
before they forget it, which they will do unless they use it again.
Yeah.
You can use this thing called a Taylor expansion and some other things. And you got to even use logarithms, and you know and even though I know perfectly well how to do it, doing the arithmetic to write this out to even 4 or 5 decimal places,
Mm-hmm. Yeah.
it's way too tedious. Okay,
All right.
so you know, people spent years making tables that would include values like that, okay? Because they had to do it by hand. Nobody does it by hand anymore, okay? But a lot of people know how because it's important. You know, there are other things that you would use that idea for. Anyhow, that's not relevant, except that I want to emphasize that we're not including the 1/2 on this table,
Okay.
okay? And on this table, there's a number that's excluded from the domain of this function. What is it?
0?
Yeah, so not in the domain, we just X it out. We don't use it. It can't be evaluated.
Right.
Now, the problem that I see when I ask people to do this is they say, oh, it's 1 over 0. There's a 0, so it must be 0. It isn't. Okay? It's undefined. And in fact, when x gets close to 0, the value of 1 over x becomes huge.
Mm-hmm.
So it would make no sense to write 0 down here. Okay?
Okay.
Okay, well, quickly, we're going to need to move on to some other things. We're a little over time already. See if you can complete the table for 2 to the x, being careful to write everything out step by step.